In the previous video, I discussed about some tricks, how to convert from one compound to another compound. Today, I will be applying all those tricks in a flowchart. Then I'll be teaching you one more trick and then we'll do a lot of practice. My name is 𝐒𝐿𝐵𝗲𝗏 and you are watching 𝐒𝐵𝗲𝗏 classes. So in our previous video, we have spoken about trick number 1, increment in carbon chain. So how to increase the number of carbon atom in the chain, that we have discussed in the trick number 1. Trick number 2, decrement in carbon chain, how to reduce the number of carbon atom in the chain. Trick 3, where we have converted single bond to double bond and double bond to triple bond and vice versa. Trick number 4, where we have converted alcohol to aldehyde and aldehyde to carboxylic acid and the reverse process also. Trick number 5, where we have seen how to convert alcohol to amine and vice versa. Trick 6, amide to amine, and last trick, that is nitro to amine and amine to nitro. So if you have not watched that video, you please go to the video number 1, part 1 of organic conversions, and then come back to this video. That will help you a lot. Okay. So today I will be writing a flow chart to show how these tricks are applied to the flow chart. Okay. So suppose I have CnH2n plus 2, that is alkane. I might have alkene with me, or I might have alkene CnH2n, which is alkene, okay, or I might have alkyne CnH2n minus 2, that is alkyne. So whether I have alkene or I have alkene, alkene or alkyne, I need to first convert that into haloalkane, because I told you that a lot of conversions can be done from haloalkane. We need to make this functional first, so we have to convert them into haloalkane. So alkene to haloalkane, we did it with chlorine in presence of sunlight. So it will convert into haloalkane CnH2n plus 1x. The general formula for haloalkane is Rx. So this is how alkene can be converted to haloalkane. Alkene to haloalkane, we will just add HX. The addition reaction will take place and alkene will be converted into haloalkane. From alkyne to haloalkane, what we will do is first we will convert alkyne to alkene with hydrogenation in presence of PD and BaSO4, which will allow this hydrogenation to do only partially, that is partial hydrogenation will take place or partial reduction will take place. Alkyne will convert into alkene, and then second step we will add HX so that it converts into haloalkane. Now once all these hydrocarbons are converted into haloalkane, this haloalkane can be treated with KCN. Nucleophilic substitution reaction will go on and Rx, Kx will come out from here and we will be getting RCN. So it will convert into cyanoalkane or alkyl cyanide. Then we can reduce it with the help of hydrogen in presence of platinum or nickel or palladium, and we'll get it as RCH2NH2, that is amine. So from haloalkane we converted it to amine. Second thing what we can do is we can treat this haloalkane with aqueous NaOH or aqueous KOH, so that this Rx will convert into ROH, that is alcohol. So now this alcohol can be again treated with PCC or PDC to convert this into RCHO, where partial oxidation will take place and we'll get RCHO. Or this alcohol can be treated with acidified K2Cr2O7 or KMnO4, acidified KMnO4 or Jones reagent, so that it converts into RCOOH, that is carboxylic acid. Also from aldehyde to carboxylic acid we can go. Aldehydes are treated with Tollens reagent or Fehling's solution, Fehling's reagent, so that they convert into carboxylic acid. Okay. Another thing is, this alkyne can be treated with red hot iron tube or red hot copper tube, where polymerization takes place and alkenes are converted into benzene. Alkynes are converted into benzene, sorry. So you can see aliphatic hydrocarbon converts into aromatic hydrocarbon. So all these things are there. Also from carboxylic acid we can take this conversion further. I'll show you that. From carboxylic acid we'll do this further. Another thing is from RX, this is haloalkane. From here, if I treat this with sodium alkoxide, NaOR, this is called as sodium alkoxide. This particular reaction is called as Williamson's synthesis. You have studied it in the preparation of ether, and we get here ROR. So you can see how the tricks are applied to get so many compounds like this. Also from carboxylic acid, I will do much more conversion. Carboxylic acid, suppose this is treated with, where I should write, I'll make it little smaller. Yes. So these carboxylic acids, these are treated with ROH. Suppose it is treated with alcohol, we get ester over here. Carboxylic acids are treated with alcohol to get ester. Carboxylic acids are treated with ammonia to get amide. Carboxylic acid plus amine and ammonia will give you amide. Carboxylic acids are treated with PCl3 or PCl5. PCl3 or PCl5 to get RCOCl, that is acyl chloride we get. Carboxylic acids are treated with P2O5 and heat. This is dehydrating agent, where it is converted into RCOO COR. That is, we can write it like this, RCOO whole twice O, that is anhydrides. Okay, carboxylic acids can be dehydrated to give you anhydrides. So all these derivatives of carboxylic acids we are getting. Okay, so this is the entire flow chart where we have used all the tricks which were taught you last time. So basically we have alkane, alkene or alkyne. First of all we have to convert them into haloalkane. From haloalkane we get number of compounds. If haloalkanes are treated with KCN, we are getting cyanoalkane first, and then that is reduced to give you amine. Haloalkanes are treated with aqueous NaOH to give you alcohol. From alcohol we can convert them into aldehyde and carboxylic acid. From carboxylic acid we are getting lot of derivatives of carboxylic acid. It is treated with alcohol to give you ester, treated with ammonia to give you amide, PCl3 or PCl5 to give you acyl chloride, and it is treated with P2O5 and heat to give you acid anhydride. Also, the haloalkane are treated with sodium alkoxide to give you ether. So many changes we can do, or so many conversions we can do from the by applying the previous tricks. To aromatic compound, and then we are going to see the conversions in aromatic compound. So let us talk about the last trick, that is trick number 8. Suppose we have ethyne, CH triple bond CH. Ethyne is treated with red hot iron tube or red hot copper tube. Cyclic polymerization takes place and we get benzene over here. So this is how we can convert aromatic hydrocarbon, aliphatic hydrocarbon to aromatic hydrocarbon. Now this benzene can be treated with concentrated HNO3 plus concentrated H2SO4, which is called as nitrating mixture, which gives rise to NO2 plus electrophile. Electrophilic substitution takes place and NO2 group gets inserted in the benzene ring and we get nitrobenzene like this. Now this nitrobenzene is reduced by FeHCl or by SnHCl. It gives you aniline or aminobenzene, or this is called as aniline. Now this aniline is treated with NaNO2 plus HCl, the temperature requirement is 0 degree to 5 degree Celsius, and this aniline converts into benzene diazonium chloride, N2 plus Cl minus, benzene diazonium chloride. Now from this benzene diazonium chloride we can prepare a lot many compounds, okay. Suppose if this is treated with copper along with NaNO2, yes, NaNO2, benzene diazonium chloride convert into nitrobenzene again, okay. If this benzene diazonium chloride is treated with CuCl plus HCl, if you remember, this reaction is called as Sand-Meyers reaction. Sand-Meyers reaction, where benzene diazonium chloride converts into chlorobenzene. Same thing we can do with CuBr plus HBr, where we get bromobenzene. We treat benzene diazonium chloride with CuCN plus KCN, we get cyanobenzene. We treat this with Ki with little bit of it, we get iodobenzene. We treat this with HBF4, we get fluorobenzene. Okay. This cyanobenzene again can be treated with H3O+. Acidic hydrolysis of cyanobenzene will give you benzoic acid. Also, benzene diazonium chloride can be, from here I'll do, it is just hydrolyzed with water, it gives you phenol. Now from phenol, if I treat phenol with CHCl3 plus NaOH, this particular reaction is called as 𝐂𝐿Base reaction. I get salicylaldehyde or orthohydroxybenzaldehyde, which is also called as salicylaldehyde. It's a name reaction. Phenol can be treated with CO2 plus NaOH. This particular reaction is called as Reimer-Tiemann reaction. REIMER-TIEMANN. Reimer-Tiemann reaction to give you salicylic acid or orthohydroxybenzoic acid. Salicylic acid is the common name. So this is how we can change the aliphatic hydrocarbon into aromatic hydrocarbon, and then we can do these many conversions in aromatic hydrocarbon. So in these two videos I have spoken about the tricks of organic conversions, and I have shown you the flow charts, how to convert from certain compounds to certain compounds. In the next videos I'll be coming up with some of the practice questions which is more frequently asked in your board papers. So please stay tuned, and thank you so much.